You open your eyes in the morning and the world explodes into being. The sun spills across your walls, painting shadows, that dance, illuminating dust that drifts lazily in the air. In that instant, everything, every color, every shape, every certainty of reality, is delivered to you on a stream of light. Without it, there is only darkness, only void. We live in the belief that photons, those tiny particles of light, are real, that they are the messengers of existence itself. But what if they aren't? What light? The very thing we've trusted to reveal the truth is itself an illusion. What if photons, the supposed quanta of light, are not real entities at all, but convenient shadows in the mathematics of physics? Imagine for a moment the cornerstone of modern science, the bridge between the universe and our eyes, between the cosmos and our instruments gone. It sounds impossible, it sounds absurd, but the deeper you descend into physics, the stranger the picture becomes. The closer we look at photons, the less real they appear. They behave like particles until they don't. They act like waves until they refuse to. They exist only when we measure them, yet they are everywhere carrying energy across the universe, and in the deepest equations of modern physics, photons might not exist at all. That is the paradox we face. If photons aren't real, what is light? And if light itself cannot be trusted, what can we begin, as we always must in the ordinary world, with the story we were told in school, a story that feels safe, a story that feels final. The narrative of atoms, electrons, and photons, the neat, almost childlike simplicity of particles pinging about the cosmos, building up the world brick by brick. In that story, photons are the messengers of light, the quanta that carry energy from one place to another. The explanation for how sunlight warms your skin or how a laser cuts through steel, it is a story that reassures us. It tells us the universe is knowable, mechanical, and under control. But the truth is far more dangerous. To even begin to see it, we have to shatter this illusion of simplicity and descend into the history of light itself. For thousands of years, light was a mystery that haunted the minds of philosophers and scientists alike. Was it a wave like ripples in water? Was it a stream of particles? Tiny bullets racing through space, the Greeks argued. Newton declared for particles, fought for waves for centuries. Humanity swung back and forth between explanations, never satisfied, always uncertain. Then came James Clerk Maxwell, whose equations in the 19th century seemed to end the debate. Light was an electromagnetic wave. He proclaimed continuous, smooth, infinite, a ripple in invisible fields that stretched across the cosmos. The scientific worlds sighed in relief. The mystery had been solved, but light is treacherous. In the early 20th century, the puzzle returned. The photoelectric effect light, striking a metal plate and knocking out electrons, revealed something deeply unsettling. If light were only a wave, it could not explain what the experiments showed. The effect demanded something discrete, something particle-like. Enter Albert Einstein, who proposed the radical idea of light quanta, little packets of energy photons. It was a bold solution, a compromise between the infinite smoothness of waves and the sharp certainty of particles. And for a while, it seemed to work. The world embraced photons as the bridge between two irreconcilable pictures. They explained lasers, solar panels, and the very operation of your phone's camera. They became as real in our minds as atoms, as electrons, as the Earth itself. But here lies the problem. Photons are not like atoms. They cannot be trapped, bottled, or touched. We cannot isolate a photon the way we can isolate an electron or a proton. Photons exist only in motion, only as messengers. And when we look closely, they refuse to behave like anything real at all. They go through two slits at once. They interfere with themselves. They arrive only when we observe them, as though their existence depends on our gaze. And in the equations of quantum field theory, photons are nothing more than ripples, excitations of an underlying field, not particles, not waves, but something else entirely. Something without form, without substance, something that vanishes if you ask the wrong question. So we are left with the unsettling possibility that photons, the very things we built modern physics upon, might not exist in the way we think. And here at the dawn of our journey, we face the most important question of all. Do we dare to follow this doubt to its conclusion? Do we dare to question light itself? Because if photons are illusions, then reality is not what it seems. And if reality is not what it seems, then everything from the stars above to the ground beneath your feet is a shadow, a mask, a fragile construct waiting to collapse. This is where our story begins. We have lived in the glow of light for too long. Now we must step into the darkness. It conceals. The theme has already been whispered to you. If photons are not real, then what is reality? But every story requires a spark, a catalyst that tears the ordinary world apart for light. That spark came not from the imagination of a philosopher, but from the stubborn results of experiment. At the turn of the 20th century, physics was basking in triumph. Maxwell's equations had united electricity, magnetism, and light into a single framework of elegant waves. It was a time of certainty, of faith and progress. Light was understood, quantified, conquered, or so they thought. Then came a small, simple experiment, shining light on a sheet of metal. It should have been trivial. Classical theory predicted that if you flood a metal plate with enough light, electrons would eventually absorb enough energy from the waves to break free. The brighter the light, the more energy the electrons should carry. Simple, obvious, but that isn't what happened. No matter how intense the light, if its frequency was below a certain threshold, the electrons refused to budge. A flood of red light did nothing, but even the faintest beam of violet caused electrons to leap away with sharp bursts of energy. The electrons cared nothing for brightness, only for frequency, only for the color of the light itself. This was the photoelectric effect, and it broke the world. Classical wave theory could not explain it. Waves accumulate energy gradually, like ripples lapping at a shore. Yet here electrons behaved as though they were being struck by discrete bullets of energy. One photon, one kick, no buildup, no waiting. Einstein in 1905 provided the daring explanation. Light came in quanta packets. Photons each carried a specific amount of energy proportional to its frequency. Red photons were weak, violet photons strong. The photoelectric effect was not a gradual soaking of waves, but a direct impact of particles. It was the birth of the photon. And yet, even as this explanation won Einstein the Nobel Prize, it opened the door to a nightmare because photons solved the photoelectric effect, but they defied everything else we thought we knew. Consider the double-slit experiment. Shine light through two narrow openings, and on the wall beyond you see interference, bright and dark, fringes the signature of a wave. This had been the proof of light's wave-like nature for centuries. But if photons were particles, how could they interfere? Fire photons one at a time, slowly, so they cannot overlap. You would expect two neat bands, each photon choosing a slit, but no, even single photons build up an interference pattern as if each one interferes with itself. Splitting, spreading, becoming a wave, and then collapsing into a point when detected. This is not behavior. We recognize this is not a particle, nor a wave, nor anything we can picture. This is a ghost. The catalyst had arrived, and with it, the cracks spread through physics. Photons, the supposed solution, had become the source of deeper paradoxes. They were at once waves and particles, yet neither they could interfere with themselves. Yet strikers, discrete units, they carried energy, yet defied the categories that made energy comprehensible, and lurking beneath it all was the question that has haunted physics ever since. What exactly is a photon? The debate raged. Some declared photons to be as real as bullets, tangible carriers of light. Others argued they were not things at all but abstract mathematical conveniences, mere symbols in the equations. The Copenhagen school insisted we abandon the question entirely. Photons were neither real nor unreal, only measurements and outcomes, but that is no answer. That is surrender. The catalyst shattered more than equations. It shattered philosophy itself, because if photons could not be defined, then reality itself could not be trusted. What we see, what we touch, what we know, all of it rested on light, and light rested on nothing. This is the paradox. We inherit every technology of the modern world. Lasers, solar panels, fiber optics, quantum computers depends on photons. We live in a civilization built on their assumed reality, and yet the deeper we probe, the less real they appear. Imagine the dread of that realization, the messenger that carries every sunrise, every color, every star in the night sky dissolving into uncertainty. That was the spark. That was the moment. The ordinary world of waves and certainty collapsed. The catalyst of photons fractured the story, and physics would never recover. Now the debate begins in earnest. Do photons truly exist, or have we been chasing shadows? The theme has been stated. The catalyst has struck. The journey into uncertainty begins. The spark has been lit, and the ordinary world has collapsed. No longer can we cling to the comfort of waves alone, nor to the simplicity of particles. The photon, this so-called quantum of light, refuses to fit any category we know. But when faced with such paradox, humanity does what it has always done. It debates, it clings, it argues, and through those arguments, the true scope of the mystery is revealed. In the early 20th century, the scientific community fractured over what photons really were. To some, Einstein's light quanta were salvation. They explained the photoelectric effect, solved a pressing puzzle, and promised to illuminate other mysteries of radiation. These scientists embraced the photon as real, tangible, fundamental, but others resisted. For them, the photon was an act of desperation, a fiction born of necessity, a crude patch on the elegance of Maxwell's waves. They could not accept that light which so beautifully fit. The framework of electromagnetism would suddenly splinter into particles. Max Planck himself, whose work on black body radiation had led directly to the idea of quanta, resisted. The notion for Planck quantization was a trick, a mathematical convenience, not a statement about the fabric of reality. The photon was to him a useful fiction, not a building block. This was the tension. Was the photon a discovery or an invention? The debates raged across Europe. At Solvay conferences, the greatest minds of physics gathered, their discussions echoing like thunder. Through the halls of science, Einstein bore Schrödinger, Heisenberg all argued, each convinced, each uncertain. Einstein clung to photons as real, but he was not satisfied either. He wanted them to be particles definite and knowable, like tiny bullets of light. But experiments betrayed him. Photons interfered with themselves, spread out like waves, refused to localize until the very instant of detection. They defied the reality. He yearned for Niels Bohr, countered with the Copenhagen interpretation. Photons were neither particles nor waves but phenomena, shadows cast by measurement itself. Don't ask what they are. He warned, only what they do. Physics was not about reality, but about prediction. To ask about photons in themselves was meaningless. But what does it mean when science, the very discipline devoted to uncovering reality, tells us not to ask what is real? The debate spread beyond physics into philosophy. If photons exist only as events, not as entities, then what else in the universe is suspect? Is reality itself a construct of interaction, not substance? Are we chasing ghosts through the dark, mistaking our measurements for truth? The cracks widened. Consider Schrödinger's wave function, which describes the probability of finding a photon here or there, but not its actual existence until it is observed. Is the photon real before measurement, or does it exist only when we look? The debate devolved into paradox. The photon both is and is not. Both travels every path and none. A riddle disguised as a particle. Then came quantum field theory with its elegant mathematics that rendered photons not as particles, but as excitations of the electromagnetic field. In this view, photons are ripples, disturbances in an underlying continuum. They're not objects, but events appearing and vanishing in the fabric of reality, like whispers on the wind. For some, this was liberation, the photon finally explained. But for others, it was annihilation. If photons are just excitations, then what is real? The field itself, the ripples, or only the equations that describe them? Even within quantum field theory, debates linger. Photons, according to the mathematics, have no mass, no rest frame, no individuality. They cannot be labeled or tracked in the way electrons can. They are fundamentally unobservable in isolation. If something cannot be observed, cannot be defined, and cannot exist, apart from interaction, is it real, or is it simply a language we use to describe phenomena we cannot otherwise explain? The philosophers call this instrumentalism, the view that photons are not things, but tools. They exist only in the way that a shadow exists. A projection, not a substance. To adopt this view is to admit that our reality is scaffolded by illusions, that the building blocks of existence are not blocks at all, but abstractions, and yet the opposing camp refuses to surrender. Realism insists that photons must be real, even if we cannot pin them down. They are the carriers of the electromagnetic force, the mediators of every interaction of charged particles. Without them, stars would not shine, atoms would not bind. Life would not exist. To call them unreal is to dissolve the very fabric of physics into mist. So the debate continues unresolved, and as we listen to it unfold, we find ourselves caught in the middle. We depend on photons every moment of our lives. The warmth of the sun, the flicker of a candle, the glow of a screen, all delivered by photons. They feel real because their effects are undeniable. But when pressed to define them, to isolate them, to declare what they are, we falter. The debate swallows us, and certainty crumbles. Imagine standing at a precipice, gazing into an abyss. On one side, photons are real, but their reality is incomprehensible. On the other, they are unreal, but their unreality is undeniable. Both paths lead to paradox, both to doubt, and so we linger on the edge, unsure, afraid, compelled to go further. This is the essence of the debate, not merely scientific but existential. Are photons real, or are they illusions? And if they are illusions, what does that say about everything else we believe to be true? The photon was meant to be an answer. Instead, it has become a question, one that gnaws at the foundations of reality itself. And as the debates raged, the experiments grew stranger, more daring, more unsettling. Each one carried us deeper into the abyss, peeling away the illusion of certainty, revealing not clarity but chaos. The debate has not ended, it has only sharpened, and it drives us toward the next stage of our descent. The moment when we leave behind the comfort of argument and step fully into the quantum wilderness, because photons do not wait for our debates to resolve. They act, they defy, they demand that we follow them wherever they lead, and where they lead the ground beneath our feet may not survive. We have argued, wrestled, and debated, but debates do not change the nature of reality. At some point, we must step out of philosophy and into experiment. We must leave behind the ordinary world of arguments and cross the threshold into the strange domain of the quantum, where intuition collapses and photons reveal their most disturbing truths. This is the break, the point where the story plunges into the unknown. The double-slit experiment had already hinted at it. Fire photons one at a time, and they build an interference pattern as if each photon somehow travels. Both paths simultaneously block one slit after the fact, and the photon nodes attempt to detect which slit it passes through, and the interference disappears. The photon behaving as though it chose a single path. Remove the measurement, and the interference returns. Light does not merely travel. It responds to knowledge. This is not the world we thought we lived in, but quantum mechanics takes us deeper. The strange rules that govern photons stretch our minds until they fracture. Consider entanglement, two photons created together in a single quantum event. Their properties linked forever. Measure one and the other instantly responds. No matter the distance, a photon here in your hand can dictate the outcome of a photon across the galaxy. Einstein called this spooky action. At a distance, he could not accept it, and yet experiment after experiment confirmed it. Entangled photons behave as though space itself were an illusion, as though distance did not exist. Reality itself bends around their bond. Then there is quantum teleportation, where the state of one photon can be transferred to another, erasing the first in the process. Information itself, carried by photons, leaps across space with eerie precision. The photon is not a traveler, but a shadow moving faster than our comprehension. And what have delayed choice experiments here? The decision to measure a photon as a wave or as a particle can be made after it has already passed through the apparatus. In such experiments, the photon appears to retroactively decide what it was. Rewriting its own history, it is as if time bends under the weight of observation. This is the world we enter once we break into two. A place where photons do not behave like particles nor like waves, nor like anything we have ever known. They are not messengers of certainty, but tricksters of ambiguity. Entities that seem to exist only in the tension between possibility and reality. In the quantum wilderness, we no longer ask what is a photon. Instead, we ask when is a photon? Where is a photon? Does a photon exist before we look? The answers twist and fracture. The photon exists everywhere and nowhere, at every path and at none, until the moment of detection forces it into being. But this moment of detection does not settle the matter. It deepens the paradox, for if photons exist only when measured, then what is the role of the observer? Does our gaze bring them into reality? Does consciousness itself collapse the wave function, birthing photons from the void? Or are photons merely records in a grand quantum ledger existing only as potential until the universe itself decrees otherwise? The further we descend, the less familiar the ground becomes. The quantum world is not merely strange, it is inverted upside down here. The rules we rely upon in daily life no longer apply. Objects do not have definite properties. Time is not linear cause and effect blur. The photon becomes the emblem of this chaos. A thing that cannot be said to exist in any ordinary sense and yet governs everything we know, and the implications stretch beyond experiment. Every technology of the 21st century that depends on photons, lasers, fiber optics, quantum cryptography works not because photons are understood, but because their strangeness is harnessed. We do not tame them. We ride their paradox. We build our civilization on ghosts. This is the true threshold we have crossed. The photon is no longer the neat solution Einstein offered in 1905. It is no longer the comforting quanta of school textbooks. It is a shapeshifter, a phantom, a ripple in a field that exists only when pressed into being. We have left behind the ordinary world of debates and entered the extraordinary world of shadows. And yet the deeper we go, the more disturbing the questions become. If photons can act as waves and particles depending on how we look, then what is their true nature? When we do not do, they vanish into abstraction existing only as potential, or do they live in some deeper realm beyond space and time, where our concepts cannot reach? This is the upside-down world of quantum reality, a place where intuition falters logic, twists, and reality itself seems to mock us. The photon is the key, but also the lock. It shows us everything we know and hides what we cannot comprehend. And so we stand at the threshold staring into the abyss of the quantum, realizing that photons are not simply elusive, they are the shadows of a deeper truth. A truth we may never grasp, but we must follow, because if photons are not real, then everything built upon them, from the stars in the sky to the light in your eye, must be reconsidered. And if photons are shadows, then what casts them? What hidden reality lies behind the veil? We have broken into two, leaving behind the ordinary world. Now the true journey begins into the heart of the photon's paradox, into the wilderness of quantum mechanics, where the ground shifts beneath us, and the truth may be stranger than illusion itself. And as we step further, we must ask, are photons the building blocks of reality, or the cracks that reveal it is all an illusion? While physicists wrestled with their equations, humanity at large continued to live in the glow of light as it had since the beginning. And if photons are the shadows of a deeper truth, then perhaps our ancestors sensed that strangeness long before science gave it a name. This is the parallel story, the B story, a thread of myth and meaning that runs alongside the science, revealing what photons mean to us, not just what they are. From the dawn of civilization, light has been our ultimate metaphor. To see is to know, to bring light is to banish ignorance. The ancients worshipped the sun not only because it sustained life, but because it illuminated reality itself. Without light, we stumble in blindness. With it, the world reveals itself. And so light became divine sacred, the essence of knowledge and truth. In Egypt, Ra rode the solar barge across the sky each day, fighting chaos to bring order to the world. In Greece, Apollo drove his chariot of light, illuminating both body and mind. In India, Surya blazed across the heavens, the visible manifestation of cosmic order. And in nearly every culture, darkness symbolized ignorance, death, or evil. While light was life, wisdom and hope, but light is not always benevolent in myth. It blinds as often as it reveals. Prometheus stole firelight's earthly twin from the gods, granting it to humanity, and for this he was chained and tormented. Moses gazed upon the burning bush and returned with his face shining so brightly that others could not look at him. To see too much light was to be consumed. It is a theme that echoes across history. Light is knowledge, but knowledge is dangerous. Even in philosophy, light became the measure of truth. Plato's allegory of the cave imagines prisoners who mistake shadows for reality. Only by stepping into the sunlight, into illumination, can they see the truth of existence. Augustine and Aquinas spoke of divine light as the source of reason and faith. Descartes saw light as clarity, the mark of certainty. And yet beneath this universal metaphor, there is unease. If light is the foundation of truth, what happens if light itself deceives us? If photons are illusions, then the very symbol of knowledge is built on a lie. Our ancestors could not know the physics of photons, but they sense the paradox. Light gives life and clarity, yet blinds and burns. It is both reality and illusion, gift and curse. In this sense, the bee story is not a detour, but a mirror. The human story of light reflects the scientific story of photons, both reveal and conceal, both sustain and destroy. The 17th century brought science and myth together. Newton, in splitting sunlight with a prism, did more than prove that light contained colors. He revealed light's hidden complexity, a truth concealed in plain sight. To some, this was an act of divine revelation. To others it was theft. A Promethean assault on the mystery of creation once again. Light's duality, illumination, and danger revealed itself. The photon inherits this tension. To embrace it as real is to accept paradox. To reject it is to reject the foundation of modern physics. Either way, we are left in the dark. The bee story also reminds us of what is at stake. Light is not just a scientific puzzle, it is the medium of our existence. Every painting, every film, every book you read depends on photons striking your eyes. Every photograph, every telescope, image of galaxies billions of light years away is delivered to us by photons. They are the messengers of beauty, of knowledge of the cosmos itself. Without them, we are blind not only to the world but to meaning. And so the paradox of photons becomes more than academic. If they are not real, then meaning itself is destabilized. What does it mean to see if the very messengers of sight are illusions? What does it mean to know if the bearer of knowledge dissolves under scrutiny? This parallel story haunts us because it strikes at the heart of our humanity. The scientist in the laboratory wrestles with equations, but the human being stares at the sunset and feels awe. The child lights a candle in the dark and feels safe. The artist paints with light on canvas. The filmmaker sculpts light into story. Our lives are woven with photons, whether they are real or not. And perhaps that is the deeper truth. Even if photons are illusions, their effects are undeniable. The myths, the philosophies, the sciences, all converge. Light is both real and unreal, both blessing and curse. It gives us the world, even if it is not what we think in this way. The B story does not contradict the A story, it enriches it. The physicist's doubt echoes the poet's unease. The equations mirror the myths. Both remind us that reality is stranger, more fragile, and more beautiful than we imagine. And just as in every Save the Cat arc, the B story carries a lesson. The A story alone cannot provide. It whispers that the stakes are not just scientific, but existential. That if photons are not real, then neither is truth as we know it, and that perhaps the very role of humanity is to live within this paradox, to see and not see, to know and not know, to walk forever in the twilight between light and darkness. But the B story, like all good parallels, is not enough on its own. It casts meaning over the scientific quest, but the quest must continue. The photon still taunts us with its contradictions, still dares us to follow deeper. And so we turn back to the experiments, to the fun and games of quantum mechanics where photons reveal their strangest tricks. Because if the B story teaches us that light has always been paradox, then the A story shows us that photons embody that paradox with terrifying precision. And together these stories carry us forward toward a truth we may not survive. This is the part of the journey where photons show us their tricks, where the universe itself becomes a stage, and light performs with a flair that borders on the absurd, if the earlier beats gave us hints of paradox. Here we see the full carnival of quantum strangeness, photons playing games with reality itself. We return to the double slit experiment, but now with all its layers unfolded, Fire a beam of photons through two narrow slits, and you get the familiar interference pattern, bright and dark bands across a screen. This is the signature of a wave, but dim the light until photons emerge one by one, tiny quantists striking the screen in isolation. You might expect two bands like bullets passing through two doors. Instead, the interference pattern slowly emerges again, as though each photon interferes with itself, spreading across both slits. Simultaneously, here the photon becomes a conjure, splitting into possibility, traveling all paths and collapsing into a single spot when observed, and the trick deepens. Place detectors at the slits to catch which path the photon takes, and the interference disappears. Now you see only two bands. It is as if the photon knows it is being watched. Remove the detectors and the interference returns. The photon performs for the observer. Its behavior defined not by the apparatus alone, but by the very active inquiry. This is no ordinary trick. It is the unraveling of reality, and yet the games do not stop there. In the delayed choice experiment, photons take the performance to another level. Imagine deciding whether to measure the photon as a particle or a wave, after it has already passed through the slits. Logic would insist that the photon's path is already chosen, but experiment shows otherwise. Your decision in the present appears to affect the photon's past. The photon behaves as though it knows retroactively how it will be observed. Cause and effect blur time itself, bends under the photons, strange rules. Then comes the quantum eraser. Here, photons are marked with which path information, a kind of tag that reveals whether they traveled through slit A or slit B. With this information, interference disappears, the pattern collapsing into ordinary bands, but erase the information, destroy the record of which path the photon took, and the interference pattern returns. Even if the erasure happens after the photon has struck the screen, it is as if reality waits undecided until we resolve the knowledge, as if the universe itself hesitates before collapsing into truth. These experiments border on the theatrical. Photons act like comedians, like magicians, like ghosts. They refuse to conform, refuse to be pinned down. They play with us, trick us, mark us, and yet through their games, they reveal the deepest cracks in reality. Consider Entanglement, another of the photon's favored performances. Two photons are born together, their properties linked, separate them across any distance, and the moment you measure one, the other responds instantly. No signal passes between them, no time elapses. It is as if space does not exist, as if photons live in a realm beyond distance. Entangled photons behave as one no matter how far apart they are torn. This is not metaphor, this is experiment, and it suggests that the photon is not simply a messenger of light, but a messenger of a deeper truth. That reality is non-local, indivisible, woven together in ways our minds can barely conceive, and yet even this spectacle is not the final act. Photons can be coaxed into states where they interfere not only with themselves, but with possibilities that were never realized. In experiments of quantum optics, photons create patterns that seem to defy logic, weaving interference from paths not taken. It is as if the photon carries with it the memory of every possibility, every counterfactual, and plays them out on the canvas of reality. This is the fun and games of quantum mechanics, but the word fun is deceptive for. While these experiments dazzle us, they also terrify. Each one chips away at the solidity of reality, reminding us that photons are not what we think. They're not particles, not waves, not objects in space. They are events, shadows, whispers in the quantum dark. They exist and do not exist. They play games not with our instruments, but with the very fabric of causality. What do we do with